All right, so what we have here is an example of the data that was collected at TriPoint near Hillcrest Drive, Antioch. And this is the drone data that we collected. I'm looking at the processed result here, and this is a 3D tab, kind of scrolling or rotating and rotating the data around a bit. That's what you're seeing here. There's a little bit of lag, but these are the layers that are developed from that, like a textured mesh and a point cloud. Essentially, it's like a scanned version of, 3D scanned version of the data here that came from the photography. So I just want to show you guys a couple little tools about this. And let's take this little kind of row of houses here. I'm going to use this line tool and kind of just go simply from one side to the other. Here, I'll pan to a kind of nadir view, overhead view. So you get that dynamic length right on the fly as the line's being drawn. There's the 3D element to this, and everything is referenced and scaled correctly. So that's how we end up getting these results. And also because of the GPS from the drone, you're getting a really accurate end product there. What I did is also push this thing called a elevation profile. So you're seeing me now scan kind of along the line and observing what that profile could look like. I mean, and this could be used anywhere that you have a line somewhere. Another measuring tool we talked about, some of these piles and the various earthworks operations going on. So I'm going to use this volume tool here over this little pile of material and kind of draw a quick outline around the base of the thing. So that's the square footage to start with, the area. But if we click that little volume button, we end up with the cut value in this case, since everything's above the ground, about 14 cubic yards in that example. And again, these measurements are very precise, which we could also check them against something else. But as I mentioned before, like in this case here, we've got three piles kind of combined together. So you have 38 cubic yards. So this stuff is down to a few percentages of accuracy when it comes to the precision, when it comes to the models, the volume. So I'm clicking over now, switching over to a 2D mode. So now we're getting that straight top down, and this is what's called a mosaic. It's actually an ortho mosaic. Ortho meaning that everything is rectified and correctly placed in its right position, and essentially it becomes a map because you have all of these items rectified. So just kind of comparing what the resolution of the imagery looks like. You see how sharp that is compared to the satellite that you'd see there. So not only do you get sharper resolution, but you also get an updated model. We're not looking at the garlic farm anymore. So some of those details, really sharp details in this case, I mean, we're picking up about an inch per pixel, an inch on the ground per pixel is how this kind of relates to one another. Just kind of showing the examples again, so we can also do the line measurement in this view. So like if we wanted to see down the road, that's about 1,000 feet almost. If we wanted to make little markers or little tags, we can use that little tool, that little pin tool. And you could say, this is the pool. Or over here, if we scan over, that's the intersection there, or that's Hillcrest Drive, right? So let's do another one like that. Yeah, we'll call that Hillcrest. You change the color around. There's several options available to kind of modifying this and putting it to be how you want to share the items with somebody. And so on the left side, as I'm clicking through, you see these are the layers that were created. So everything gets stored on the web in the cloud as part of this service. So one more item here is like if we wanted to do an inspection. So let's say we wanted to kind of get a clear view up close of this mosaic and say like, oh, that playground there, what does that look like in the original photography? Maybe it's kind of a little bit blurry like in that example. So we see, make a little mark of where that item is, or where those features are. We can kind of scroll through the different images to see, where is that related to the mosaic itself. You can save the inspection. That's good for maybe marking out, whatever you might find, cracks in the pavement, or a bad trench or something, or I don't know, whatever you guys are interested in observing. And so what I just clicked was share. This is how I'm giving it to you, but this is how you can also provide to other people. Click that little button and then copy the link. And then you could send this over to someone and they can go about making their own measurements. That's it.